This is a lesson in two parts. The first part deals with projectile motion, while the second part deals with Newton's universal law of gravitation. At the end of the lesson, the learners should be able to recognize projectile motion and resolve the velocity of the object into rectangular components, particularly vertical and horizontal components. To recognize and use the relationship between the universal gravitational force and the masses involved, as well as the distance between the masses. And to calculate the gravitational forces using Newton's universal law of gravitation.
As I have said initially, that today I want us to talk about these two things. They are related, a projectile motion and the universal law of gravitation. Projectile motion. What is a motion first?
A motion is movement.
And it depends how fast and how slow is that motion. But once there is a movement, there is a motion. I would like to ask two volunteers to come up so that they will demonstrate.
When learners, as everybody, when they do things by themselves, they tend to understand them better than when you just explain the things. So participation, and especially in science, is very, very important.
And I want you to tell me, what are you observing? Okay, can you start, Amanda?
In the first demonstration, the learner stands still while throwing the ball up and down.
What have you observed? I don't want to talk to one and the same people. We are so many here, about 50.
I'm observing the ball. It's been thrown up, then come back without moving forward, but it's moving high and come down again.
The ball moves up, then it comes back. In other words, it moves up, it comes back to Amanda's hand.
In the second demonstration, the learner walks across the room while throwing the ball up and down.
What did you observe?
While someone was throwing the ball, it was moving with two velocities, the upward and the horizontal velocity.
It was moving with the same velocity, but in two directions, the upward direction and the horizontal direction.
Let me draw it here. While it is moving up, it is also moving towards this direction. In other words, if you observe the ball against the board, you will see that the ball is also moving like this. It's like it is falling. If you can throw the ball right up, then you start moving and throwing it right up. Will it come to the same point?
I think it's because you have changed the direction and the ball will come down where you won't be visible.
Who would like to comment?
It won't go forward because it is experiencing only one direction, vertical direction only.
It is important in projectile motion that if a motion is at an angle, it has got the components, the vertical and the horizontal component.
The teacher now allows for the learners to ask questions to strengthen their understanding.
If you are in the space, like you throw the ball, it takes time to become down like when you are in the air. So I've got confused why it takes time to become down. Sometimes going away in the space.
What do you think? It's his question.
Because in the space there is low gravitational force than in the earth. Because in the earth there is high gravitational force.
Your question will be answered very well once we get into our second aspect of a universal law of gravitation. Okay? What I want you to do, I want you now to tell me, to show to me, when we're throwing a ball, okay, which group is going to demonstrate for us? Right, you may use this ball, you may use this space And you may use this chalk. You must change the angles.
First of all, let us clarify the point that we are talking of the distance. By range, we are talking about the distance that a projectile will cover. Now, at different angles, it will cover different distances. But this is assuming that the conditions are kept the same. So that leaves the velocity with which the projectile leaves the hand, or leaves whatever source it is coming from. That has to be the same if you are going to compare the different measurements.
The learners have now been given a problem to solve. They first have to predict at what angle they would have to throw an object with a given speed to make it go furthest. They are given the opportunity to try and work this out by practical testing. By the end of this activity, they should have some sense of the range increasing up to an angle of 45 degrees above the horizontal and then decreasing as the angle increases further. The flatter the throw, the smaller the vertical component of the velocity and the quicker the ball returns to the ground. The steeper the throw, the smaller the horizontal component of the velocity and the shorter the distance that is traveled in the available time. At 45 degrees, the time and horizontal velocity combine best to give a long range for a given velocity of throw.
I think 45 degrees, which is half of 90, is an angle whereby when you are throwing the ball, it can go the longest distance. Do you all understand? Did you observe it here? If I throw this chalk up, what is happening? It becomes attracted. This is the earth, this is the chalk. Can you see the small chalk there?
It is unlikely at this level that the relationship between the gravitational force between two objects should be understood. The learners should, however, recognize that the gravitational force between the two objects depends directly on the masses of the two objects and inversely on the square of the distance between them.
What happens to a force when you increase the distance between two bodies? Yes?
When the distance is increased, the force decreases.
In this case, in the universal law of gravitational, the gravitational constant is symbolized by G. Okay? Then M1, M2 over R squared. This is the same as this. And then this is a combination of the above. I'm going to give you these sheets. Each group is going to write its own solutions here. I want each group to come and present their solution up here.
The learners now have to work in groups and solve the given problem.
Awuzobathaza usuconvertile uG sawusa kg. For that. Then square it.
Number 2 is distance between A and B is halved.
You know, if my distance is halved,
Yeah.
that means the gravity, I will increase the gravity.
Multiply force by 2.
Did everybody get this answer? Got this answer? All the groups got this answer. Right, when you're doing these problems, I'd like to emphasize that, make sure that at the end, you don't forget the units, okay? Even if you did not put the units there, but at the end, if you're calculating force, must put Newton. This is another thing. Make sure that you square this distance. Some people, they've got a tendency, of when they are calculating this, they just put numbers and they forget to square the distance. I think it's okay. Are you all happy? Yes. Did you all understand what we've been doing today? Yes. Thank you very much. It is very much important that the learners should feel that physics is what they experience every day. Therefore, it's important that you use the things that they usually use in their everyday life. In other words, you have to make physics to be live. And once they have that feel, it becomes easy for them to understand and to enjoy it.
Hi viewers at home, we have just watched a video and I would like us to talk about it. At the studio today we have Mike,
hello, Tembi.
Kanyi,
Yes, Tembi.
Feroza.
Hi.
Guys, let us talk about the teacher and look at what he did teaching this topic on this particular lesson. The teacher used a specific teaching strategy. What do you think about this teaching strategy, Mike?
Well, he used the principle of involvement. He involved the learners in answering questions and being involved in the very simple demonstrations which he was incorporating in the lesson. And they were very simple indeed, simply a matter of throwing a tennis ball. And so the lesson related directly to everyday experience, and so that was a nice feature of the lesson.
While talking about the two tennis balls, Kanye, the teacher actually brought in two volunteers. One volunteer had to throw up and down the ball at standstill, and the other one had to move. What do you think he was trying to show there?
I would say he was trying to make them look at it from a science point of view, in the sense that they're used to throwing the ball, but now what is the ball doing in terms of motion, so that they could identify the vertical motion in the girl who was throwing it just standing still, and then the two components, the vertical and the horizontal motion, when was it a girl or a boy, I can't remember, who was throwing it while moving across the room. So in a way it made them see those components exactly, especially when he went on to draw or represent those in a diagram on the board. Yeah. And
Feroza, do you think he was successful in achieving his goal?
Yeah, I think so. I mean, it came across quite clearly to me that there was, he was trying to put across vertical and horizontal components of projectile motion. So I think it was quite effective in the way he came across.
And Mike, what do you think is the major problem in teaching this particular topic at an FET phase?
Well, the whole issue of components is something that many learners find very, very difficult. It involves quite a number of cognitive skills, working with angles, working with trig ratios, the difficulty of trying to look at motion in two different directions simultaneously is something which is conceptually difficult for many learners. So it's not an easy topic, and indeed I'm subject to correction, but this topic has been largely removed from the new syllabus. Yes. They still do the vertical motion, but it's now considered. I don't know whether I completely agree with the curriculum developers, but some of them consider that it's too challenging to expect learners to handle the vertical and horizontal components simultaneously. Nevertheless, I still think there's some benefit in teachers at least talking a little bit about it to their learners.
And what sort of advice could you give to a teacher in teaching this particular lesson or topic? Feroza, what do you think?
The difficult thing about projectile motion are the two components, vertical and horizontal, and especially when it comes to calculations. So, I would suggest that they try and, hone in on the calculation aspect and try and help kids, especially when it comes to trig ratios, help them with the mathematics of it.
And one thing that I thought maybe the teacher was going to do when they were busy throwing the ball on the floor, I thought maybe they were going to be putting some mark to measure the distances so that at the end they'll be able to do the calculations.
At the first instance, they threw the ball and then they made a mark on the floor. and then they had to figure out what angle did they throw the ball at. Until at the end, he said the 45-degree angle seems to be the best angle where they can throw it the longest. Had that been successful, that would have been a core or a critical part of the lesson, because it brings out the relationship between the angle and the distance covered very well.
Okay. And in between, the teacher kept on asking questions. How effective do you think those questions were?
Well, the one thing that I did notice and would like to comment on, that he emphasized that he didn't want the same people to be answering all the time. He said something to the effect he didn't come here to listen to one person,